Welcome to a video on section 5.3, which is looking at proving that a quadrilateral is a parallelogram. So how do we know if we have a quadrilateral if it is a parallelogram? Well, first of all, over here, this is not on your notes, but it's just an example of a shape that looks like a parallelogram. It's got four sides, so it's definitely a quadrilateral. So we're going to go over the different ways that we can be 100% sure that it is a parallelogram. Now, first of all, you can't go by what it looks like. Often they're going to give you things that look exactly like a parallelogram. So we need to go by evidence, information, markings on the diagram, things that we can deduce from information we know, things like that. So to begin with, the easiest way to be 100% sure that you have a parallelogram is if it follows the definition. The definition, remember, is that it's a quadrilateral with two pairs of opposite sides that are parallel. So if you see parallel marks or they tell you they're parallel marks could look like this or they can look like solid triangles. If you have that information, then you know that it is a parallelogram. And that is by the definition. Okay, so that's our first one. Does it have two pairs of opposite sides that are parallel? And if the answer is yes, then you're done. Yes, it is a parallelogram. And remember that this is by definition. Okay, that's definition for abbreviation. Okay, so that's the easiest one. The next one is if you have information about the side lengths. And we know that in a parallelogram, the opposite sides are congruent. So if you see that the opposite sides are congruent, both pairs, like that, for example, then you can say that the quadrilateral is a parallelogram. So that's one way that they could show it. Another way that they could show it or describe it is by giving numbers that show that they're the same. So if this is 5 and that's 5, and this is 7 and this is 7. Okay. An important thing to note is if you only have one pair of congruent sides, that is not enough. There are other shapes that have four sides that have one pair of parallel sides but are not parallelograms. Even if you think it looks exactly like a parallelogram, that's not enough information. Okay, has to have both pairs. Next, let's look at the angles. All right, we know in a parallelogram that the opposite angles are congruent. So this angle and that angle would be the same. So they'd mark it like that. If you know that both pairs of opposite angles are congruent, then you can say that it is a parallelogram. So once again, we have the word congruent. Does it have two pairs of opposite angles that are congruent? Must have both pairs. So if you only see one pair, not good enough, not a parallelogram. All right. Next, consecutive angles. Consecutive angles, remember, are the angles that are next to each other. So for example, this pair right here is a pair of consecutive angles. This is also a pair. This is a pair. This is a pair. So you have four pairs of consecutive angles. So let's go ahead and take a look at some examples. Let's say that you know that this angle is 100 degrees. And you know that this angle is 80 degrees. Those are supplementary, as they are in a parallelogram. However, that is not enough information to show for sure that it is a parallelogram. There are some other shapes that have pairs of consecutive angles that are supplementary. So you need more information. If we know, say for example, that this is also 100, then we have two pairs of consecutive angles. Then we know that the angles in a quadrilateral add up to 360. If you do the math here, let's see, 280 in this example, we subtract, we get 80. We get that this is 80. And so we get all pairs are supplementary. You can also see that opposite angles are congruent, as in the last one. So to test, you need at least two pairs of consecutive angles that are supplementary, which means they add up to 180. Okay? All right. Then we have the diagonals. Okay, we saw that if we draw the diagonals, remember the diagonals go from vertex to vertex that are not already connected by side, so this is a diagonal. And here's another diagonal. We saw that the diagonals bisect each other, which means this is a midpoint for both. They cut each other in half. So if this was 5, that's 5. If that's 6, that's 6. So we can check, do its diagonals bisect each other? Or if you prefer, cut in half. Okay. If you see this, it has to be a parallelogram. In fact, this is one of my favorite ways to draw a parallelogram. If you draw the diagonals first, so I usually take a ruler and I measure out a segment, and then I find the midpoint with the ruler. I cut it in half, and then I draw another segment that goes through that midpoint, and I have to make sure that that is also the midpoint of this one. I'm doing this freehand right now, obviously, so I don't know if this is actually going to work. And then you connect these 4 points, and you get a parallelogram. It's okay. It's totally freehand. If I was doing it neat with a ruler, it would look a lot better. All right, and our last one. The last one is a little weird. We've done all the characteristics, right? We've got all of them, but there's another one that isn't really one of the characteristics of a parallelogram backwards. Okay, in this one, if you look at one pair of opposite sides, it doesn't matter which pair. I'm just going to choose this pair, but it could work for the other pair. Okay, and you see that that pair is two things. First, that pair is parallel, and the second thing is you see that they are congruent. So if you notice that they're parallel and you see they're the same length, these marks mean different things, okay? So it's not like I'm being repetitive. One of them means they're going in the same direction, they won't cross. The other one means they're the same length. If both of those things happen to the same pair of opposite sides, it is a parallelogram. The best way I can describe this is it just kind of looks like a box hinge, kind of like this. You have a lid here. I don't know if I'm describing this correctly, like a toolbox or something. And then when you close it, you'll see that these two kind of stay in the same spot. It's I don't know. I'm not explaining it very well. Anyways, let's write this down. Is one pair of opposite sides congruent and parallel? Okay, again, it could be this side. You don't need to know anything about any angles. You don't need to know anything about any of the other sides. Okay, and this one's actually pretty easy to prove. If you draw one of the diagonals, with this information you can prove that the triangles are congruent. Okay, the parallel stuff would give you that alternate interior angles are congruent. So you have an angle. We already had a side, and then we have the reflexive side. So by side angle side, both of these triangles are congruent. Once you have proven that those two triangles are congruent, you can prove all sorts of things like, oh, well, these sides are congruent. oh, these angles are congruent, and then, oh, okay, oh, well, these are parallel to, you can get a parallelogram from there. Okay? All right, that's it for this lesson. Thank you for watching.